multiple instruction and multiple data, and then we are seeing vector processing. So first classification is a single instruction and single data. We see the what is a single instruction and single data. First, single instruction and single data is a represent the organization of single computer containing a control unit and a processor unit and a single memory unit. Actually, in a single instruction are executed sequentially. Yes, sir. Okay, sir. Yes, sir. Instructions are executed sequentially, and the systems may or may not have internal parallel processing capacity. The most convenience computer have single instruction and single data architecture like the traditional and non-Newman computers. So actually what is working in a single instruction and single data, uh, so parallel processing in this case may the achieve by the means the multiple function units or a pipeline processing. So actual we see the pro- actual processing of single instruction and single data. So if we give input, so what we have to perform some addition, subtraction. Uh, the only one if we have performed three operation, addition, subtraction, and multiplication. In this single instruction and single data, only one operation will perform at a time. So if we give input as input and CPU get calculate the addition, then store it into memory, then for the second instruction if you have to subtract, then subtract this, calculate it and store it into memory. In single instruction and single data, uh, only one operation is executed at once time, and it so instruction are decoded by the control units, and then the control unit send the instruction to the processing unit for the execution. Now next is a single instruction and multiple data. Actually, no, previously single instruction and single data used in first computer first computer with Windows 11 or Windows 98 we use. Now we see the single instruction and multiple data. It is represent an organization that includes many processing units send the supervisions of a common control unit. The process receive the same instruction from the control unit but operate on a different items of data. The share memory of units must contain multiple modules so that it can be communicate with all the process simultaneously. In a single instruction, multiple data. Uh, in previously, only one instruction is executed at a time, but operation is performed. Here, uh, multiple operation is performed at a time, but output is given single instruction. So firstly, we see the mainly dedicate single instruction multi-data to array processing machine. How vector is processing can also be see the part of the group. Here, the example of single instruction and multiple data is a Pentium 3 and Pentium 5. Uh, next classification of phenomena taxonomy will explain Pranav.
Good morning, sir. My name is Pranav Thorat, and I am explaining remaining two classifications from Flint's classification, that is MISD and MIMD. MISD means multiple instruction and single data. MISD structure is only for theoretically. No practical system has been constructed using this organization. In MISD, multiple processing unit operates on a single data. The best example of MISD is systolic architecture. In this architecture, suppose there is some data in a memory. First processor take some data from memory and perform addition operation on it, and then second processor perform another operation on the same data, and another processor perform different operation on a same data and store it to the memory. That means different processors perform say different operation on a same data. That is multiple instruction in same data. Second is MIMD. MIMD means multiple instruction and multiple data. In this organization, all processors in a parallel computer system execute different instruction on different data. In this, in this, each processor has separate program and instruction generated from each program. MIMD perform different in MIMD, different processors perform different operation on a different data at the same time. That means one processor perform addition operation on A and B. Second processor perform multiplication operation on C into D, and another processor perform some another operation on another data. That means multiple processor perform multiple operation on multiple data. That is that is MIMD. The example of MIMD is Intel Xeon Phi. Uh, Thank you. Start explain Chetan.
Good morning, everyone. Vector processing. In computing, a vector processor is a central processing unit of CPU that implements and instructions that operate on one-dimensional array of data is called vectors. Vector processors can greatly improve performance on certain workloads, notably numerical simultaneous and similar tasks. Two popular architectures of vector processing is SIMD and MIMD, means single instruction multiple data and multiple instruction multiple data. Medical diagnosis, data analysis, weather forecasting, human genome mapping and GIS data are some examples of vector processing. A vector processor that has the capability for vector processing. Advantages of vector processing is program size is small as it requires less number of instructions. Thank you, sir.
Thank you, sir. That is all about the uh, Finner's taxonomy and their classification. Thank you. Thank you, sir.
No, sir.
Uh, Single instruction, single data is not used, sir. Because only one operation is performed at a time. So this is not used, sir. Yes, sir. Uh, Other is single instruction and multiple data is also not used because Actually, Windows first computer is implemented in this single instruction and multiple data is used. Next one. This is used, sir. Hello. Okay, sir.
Yes, sir. Sir, online videos or MLS, LMS. Multiple interaction, multiple data.
Yes, sir. Okay, multiple instruction, multiple data. Sir, question repeat. Further divided, sir. Mm, multiprocessor system, multiple processor running at simultaneously. Thank you, sir.
Yes, sir. I'm sharing the screen.
Good morning, sir. We are presenting on multiprocessor network topology. Here are the contents. First is the introduction to multiprocessor network topology. Second is the multiprocessor network topology, and third are the various types of net. Yes. And third is the various types of network topology. So first of all, we are explain about multiprocessor network topology. Multiprocessor network consists of multiple processing units connected via some interconnection network plus the software needed to make the processing units work together. So multi-core chips require networks on chips to connect cores together. Network cost include number of switches, number of links on a switch to connect to the network, the width per link, and the length the links when the network is mapped into chips. The motivation for exploring the other interconnect topologies is to allow for the possibility to optimizing various aspects of its design. For example, one may choose to optimize the latency or scalability of an interconnect system, or the actual cost of its real world implementation might be worth optimizing instead. So there are various types of network topology like bus, uh, ring, fully connected or mesh, 2D grid, omega or crossbar. So first is the ring topology. Ring topology is a network configuration where device connection create a circular path. Each network device is connected to the two of uh, two other two like points on a circle. Together, device ring topology are referred as a ring network. Ring topology allows packets to travel only in one direction called unidirectional ring network. Other conveys data to move in either direction called bidirectional. So there are some advantages of ring topology. Uh, so first is the um it minimize the packet collision. uh, it provides the long distance communication. uh, so unidirectional ring network provides the high speed. It is less costly. um, it is less costly. It has better performance than the bus topology. It has some drawbacks like one one bre- one break in a single cable can cause the entire network can cause the internet wire. Uh, then second is the it is slower than the LAN. Third is the addition and removal of any node is quite difficult. Is quite difficult. Uh, so Divya, can you take further charge?
Yes. Good morning, everyone. So I'm going to explain fully connected network. A network that connects processor memory nodes by supplying a dedicated communication link between every node. Means in this fully connected network, processor and memory nodes are connected to each other via some communication medium, and there are multiple communication cables between this processor and memory nodes which connect processor and memory nodes. In this fully connected network, it is also called as a complete topology or a full mesh topology, and it is simply a network topology in which there is a direct link between all of the pairs of its nodes. Uh, Fully connected network is quite complex because in this multiple cables are connected to the each other between processor and memory nodes. Uh, that
Thank you.
In our laboratory, bus or ring topology is used. Bus or ring topology. No, sir, only one. Only one, that is bus. Yes, because to the only single cable, multiple nodes are getting, means computer are connected. Not exact. Yes, yes. To the single wire, many nodes are connected. Yes, sir. Yes. Uh, no. No, sir. Yes, sir.
Sorry, sir. But the switch decide which topology we are using. Ring.
In ring topology, nodes are connected in circular manner, and in bus topology, nodes are connected in the sequentially, means only one communication cable. Yes, sir. When one node is getting failure, all nodes are getting failure. No, sir. Just watched video on the LMS. Yes, sir. Yes.
Yes, sir. I will share the screen. Yes, sir. Good morning, all. I am Ashwini Gilge. Today we are going to present our CIA presentation on the topic of multiprocessors and hardware multithreading. So, this is the content of our presentation, that is threads and process, implicit and explicit multithreading, approaches to explicit multithreading. Then we will see in this interleave and block. Then next is the scalar processor approaches. Then we will see in this single threaded scalar, interleave multithreaded scalar, and block multithreaded scalar. So let's come to the point. That first one is definition of threads and process. Good morning all, I am Ashwini Gidge. Today we are going to present our CIA presentation on the topic of multiprocessors and hardware multithreading. So here is the content of our presentation, that is threads and process, implicit and explicit multithreading, approaches to explicit multithreading. Then we will see in this interleave and block. Then next is the scalar processes approaches. Then we will see in this single threaded scalar, interleave multi-threaded scalar, and block multi-threaded scalar. So here is the definition of threads and processes. Threads in multi-threaded processors may or may not be same as software threads. Means they may be different. So here is the process. Here is the definition of process. Process is the instance of program running on computer resources, ownership, virtual address space to hold processes, image scheduling, execution process, switch. Then next is the definition of thread. Thread is the dispatchable unit of work within the process includes processor context which include the program counter and step pointer and data data area for stack thread execute sequentially means one by one. Then next is the interruptible. This is the processor can turn to another thread. Thread switching processor between threads within the same process typically less costly than the process switch. Then please Kalyani continue.
So my name is Pawar Kalyani. So here we comes what is implicit and explicit multithreading. As we know, all commercial process and most experimental ones use explicit multithreading. It's concurrently execute instruction from different explicit threads, interleaves instruction from different threads on shared pipelines or parallel execution on parallel pipelines. So in implicit multithreading is concurrent execution of multiple threads extracted from single sequential program. Implicit threads defined statically by compiler or dynamically by hardware. So next we will see uh, approaches to explicit multithreading. In this, first one is interleave. Fine grain process deal with two or more threads context at a time. Switching threads at each clock cycle. If thread is blocked, it is skipped. Then second is block. Coarse grain. Threads execute until even cause delay. For example, catch miss, effective on in order processor. Vaishnavi, please continue.
Thank you, Kalyani. A very good morning to everyone. So here I'm here to explain you the topic that is the scalar processor approaches. Firstly, we're gonna see what the single-threaded scalar is and the interleaved multi-threaded scalar. Firstly, we will go with the single-threaded scalar. It has a simple pipeline and there is no multi-threading. In interleaved multi-threaded scalar, easiest multi-threading to implement, switch threads at each block cycle. Pipeline stages keep close to the fully occupied hardware needs to switch, and hardware context between the cycles. Next slide, please. So here is another point that is blocked multi-threaded scalar. So it is the threaded executed until latency event occurs, would stop pipeline and processor switches to another thread. So now here is another point that is the parallel simultaneous execution of multiple threads. So the different executions in a different formats like parallel and simultaneous execution is explained. So firstly we'll go with the simultaneous multi-threading. So it has an issue with the multiple instructions at a time, and one thread may be fed at horizontal slots. Instructions from two or more threads may be issued. With enough threads can issue maximum number of instructions at each cycle. And now here we are with the cheap multiprocessor. So it has a multiprocessors, each has two issue subscalar processor. Each processor is assigned thread, can issue up to 2 instructions per cycle per thread. So here the reference we have taken is the ebook, and thank you so much. Multiprocessing can be termed as execution or scheduling of a number of processors.
In multi-threading, minimized system resources are used.
Explicit and implicit. Implicit multithreading is a concurrent execution of the multiple threads we can say.
So implicit. Yes. Sir.
Mm, I guess explicit. No, sir. I guess it's because of different threads or
No, sir.
No,
No,
sir.
sir. One presentation is remaining and that conduct Monday or Saturday. Okay, sir.
Yes, sir.